Hi everyone, welcome to our presentation. Today, we will be discussing our implementation of an API gateway. But before diving into the technical details, allow me to introduce this amazing team behind this project. I'm Francis Tenao, and I took charge of the API gateway's development, including integrating routes and middlewares, as well as creating the rate limiting and sanitized middlewares. Joining me are my talented teammates. First is Rhea Bete, who developed the logging middleware, followed by Marjorie Polistico, who worked on the authentication middleware, Almarie Maestrado, who implemented the caching middleware, and Malto, who created the course middleware. Now, before we dive into the service functionality, let's begin by discussing each middleware in detail, starting with the authentication middleware.
Let me start with the first middleware added to our API gateway. Middleware plays a key role in server architecture, acting as a processing layer between the client's request and the server's response. This specific middleware ensures the security of our API by authenticating incoming requests. The purpose of this middleware is to validate that every incoming request includes a valid authorization token. It helps safeguard the server from unauthorized access and ensures that only authenticated users can interact with the APIs. This middleware starts by checking for the presence of the authorization header in the request. If it's missing, a 401 unauthorized error is returned. The token is extracted from the header and validated by the isValidToken function, which currently serves as a placeholder for future validation logic. If the token is invalid, the middleware blocks the request and responds with another 401 error. Now let me show you how this middleware works. We'll call an API with an authorization header with bearer token as its value. As you can see, we successfully called the API. Now, if we remove the token, let's see what will happen. As you can see, it demands us to be authorized. That will be all for the auth middleware.
Now I'll explain the caching middleware integrated into our API gateway. Middleware like this helps improve the efficiency and performance of the server by temporarily storing responses for use. The purpose of this middleware is to reduce server workload and improve response time by caching API responses. It achieves this by saving responses by cached file and serving cached content for identical requests within a specific time window. This middleware generates a cached daily traffic key for each request by combining the request URL, method, and body. Checks if the corresponding cached file exists and if it's still valid based on a 5-minute expiration time. If valid, the cached response is sent to the client immediately. Otherwise, the middleware starts an output buffer to capture the response, which is saved to the cache at the end of the request lifecycle. As we can see here in the directory, we can see that we have 3 JSON files containing the caches, and if we open this file named rate limit, we see that the start time of the last rate limit was cached. And that is all for the cache middleware.
Now, I'll introduce the cross-origin resource sharing middleware that we've implemented in our API gateway. So, CORS is essential for enabling secure communication between servers and client applications hosted at different domains. The purpose of this middleware is to manage cross-origin requests by allowing specific domains, methods, and headers to access our APIs. This ensures compatibility with web applications while maintaining server security. This middleware starts by dynamically allowing requests from the origin specified in the HTTP origin header while enabling credentials and caching the course policy for 1 day. For pre-flight requests sent with the options method, it specifies the allowed HTTP methods and headers to inform the client application what is permitted. So, if the request is pre-flight, it exits after setting the headers, ensuring smooth cross-origin communication. And that would be it for the course middleware.
Next middleware is the logging middleware that is added here in our API gateway. Logging is a critical component in any server infrastructure as it helps in monitoring activities and debugging issues effectively. The purpose of this middleware is to record every incoming request and their corresponding responses, including vital details such as client's IP address, the request method, the endpoint, the status code, and the response body. Now, this ensures that we have a comprehensive activity trail for debugging and for analytics. This middleware generates a log entry containing the timestamp, the client's IP address, which is retrieved using the getClientIP function, the request method, the URI, the status code, and of course the API response. Now, these entries are being saved in the log file, which is named gateway.log. And this getClientIP function here checks various headers to extract the client's IP address, ensuring accuracy even when behind proxies or load balancers. Now, if we're going to request from an API, the results will be saved right in the log file, which is the gateway.log. Now let's check. So after we retrieve the data, let's check the gateway.log file, and as you can see here in the latest row, we have the timestamp of the latest log, the IP, the method, the URI, the status code, and lastly, the response. And that's all for the logging middleware.
Now heading on to the rate limiting functionality we added to our API gateway. So this feature enhances the existing controllers by protecting our APIs from excessive requests and ensuring fair access for all users. Now, the purpose of the rate limit middleware is to control the number of requests a client can make to the server within a specific time frame. This helps prevent abuse such as spamming or overloading the server with excessive requests, often referred to as denial of service or DDoS attacks. By limiting the request rate, it ensures fair usage of resources, improves server performance, and provides a better experience for all of your users. Now heading on to our code. The code I implemented begins by identifying the user's IP address and storing its activity in a cache directory. If the directory doesn't exist, the code creates it. Ensures a reliable storage mechanism for rate limiting data. Next, it tracks the number of requests made within a set time window, in this case 60 seconds. Each request increments to the count, and if the limit of 5 requests per minute is exceeded, the API returns a 429 status code with a too many request error message. Additionally, the script receives the request count when the time window expires, ensures that users can resume activity after a brief cooldown period. By adding this functionality, we've improved the robustness of our API gateway. Now let me introduce to you how the rate limiting function works. As you can see, I have opened Postman where all of the endpoints from the previous group have been saved. Now let us try accessing the get products. I will click the send button once and to create a request to the API. As you can see, we receive the data. Now let us proceed on trying the span click and send button as if we're trying to call the API multiple times. And let us check if it will trigger the rate limiting. And as you can see, it displayed too many requests. That's all for rate limiting middleware. Now I'll walk you through the input sanitation middleware we've implemented in our server. Input sanitation is a critical layer of security that helps protect our system from malicious data or attacks. Now, the purpose of this middleware is to analyze and sanitize all incoming request data. It ensures that inputs conform to a safe and valid format, preventing potential injection attacks like SQL injection, which could compromise our database and server security. Now, moving on to the code, it scans each field using request, recursively sanitizing nested inputs. A regex or regular expression identifies disallowed characters, and if invalid input is detected, it halts the process, returns a 400 response, and notifies the client with an error message. Now let me show to you how this works. Since I've opened my Postman, let's try to access the login API. Now, one SQL injection example is typing out a SQL attack. In this case, we have an email with its value of x plus x equals or equals 1. And let us check. Now, as you can see that this is a example of SQL attack as it returns an error. Now I've discussed to you each the middleware. Let's transition to the server code. Since we're implementing an API gateway, it's important to understand its purpose. An API gateway acts as a single entry point for client requests, handling tasks like routing, authentication, rate limiting, and more. Now, it simplifies client-server communication by centralizing these functions, improving efficiency and scalability. Now, in my code, I've integrated several key components to make our API gateway more functional and efficient. First, I loaded all the necessary dependencies, including the middleware files, controllers, and the database utility. Now, I ensured all middlewares are applied in sequence, rate limiting, sanitation, and course handling, which helps secure and optimize incoming requests. I've also added a public routes definition to allow authentication access to endpoints like sign in and sign up. For protected routes, the auth middleware ensures only authenticated users can access those endpoints. Now I implemented a routing mechanism that dynamically matches request URIs and HTTP methods to their respective controllers and methods. If a route matches, the corresponding controller processes the request with the necessary parameters. Otherwise, default 404 response is returned for unmatched routes. Finally, I included caching to store responses for specific requests, reducing load on the server, and added request response logging to monitor API activity and execution times. Now, heading on to the issues that we have encountered during our development. So there are actually 4 issues that we found. Number 1 there are where consistencies between the namespace and the actual files of the auth folder, so leading to difficulties in auto-loading classes and referencing them correctly within the code base. Secondly is the difficult organization of files where within the project is not optimal, making the code base difficult to navigate and understand. Next is the column mismatch in queries. The issue is the column names in the queries, especially in the user-related functions, did not match to the actual column names in the database. For example, like the query used session tokens or session-tokens, but the correct database columns was session token. So this led to errors in executing and inconsistent behavior. Lastly, for SAMP, MySQL unexpectedly turned off if it's going to turn on. And the solutions for this is we manually change the files from the existing controllers from the groups. And next is reinstalling the SAMP SQL and making it run again. So that's all for our presentation, and I hope you learned a lot from this implementation of the API Gateway. If you wish to check our GitHub repository, there's a link down below. Thank you so much for listening.